In the 1960s, a grand planetary tour to study the outer planets was proposed. It was an ambitious plan to send unmanned probes to the outer planets of the outer solar system. The grand tour could exploit a rare, unusual, and favorable alignment of the planets Jupiter, Saturn, Uranus, Neptune, and Pluto. This planetary alignment would occur in the late 1970s and would not occur again for 175 years. This special alignment of these planets could allow a probe to be sent to Jupiter and use that planet as a gravitational slingshot to extend its trajectory to the other planets further out in the solar system. Gravity Assist would enable a single probe to visit the four gas giants, Jupiter, Saturn, Uranus, and Neptune, while requiring a minimum amount of propellant and a shorter travel time between planets. The NASA space probes Voyager 1 and Voyager 2 have been exploring our solar system to the outer planets for more than 34 years. Many of the scientists now working on the Voyager project weren't even born when the probes were launched in the 1970s. Originally, the Voyager probes were designed as part of the Mariner program. Voyager 1 was called Mariner 11, and Voyager 2 was called Mariner 12. The program progressed, however, and the name was changed to Voyager. Voyager 2 was actually launched first on August 20, 1977, and Voyager 1 followed 2 weeks later on September 5, 1977, and was sent on a faster, longer, and more circular trajectory. Remote control programming was used to endow the Voyagers with greater capabilities than they had when they left the Earth, enabling their two-planet mission to become a four-planet mission. Voyager 1 could have been sent to Pluto after Saturn, but instead was sent on a trajectory which brought it close to Titan, Saturn's planet-sized moon, eliminating the Pluto flyby. Voyager 2's trajectory could not be bent to bring the probe by Pluto after the Neptune flyby in 1989. Eventually, Voyager 1 and Voyager 2 explored all the giant outer planets of our solar system, 48 of their moons, and the unique system of rings and magnetic fields that those planets possess. On December 10, 1977, Voyager 2 entered the asteroid belt. 9 days later, Voyager 1, traveling at a greater speed, overtook Voyager 2. In June of 1977, the primary radio receiver failed on Voyager 2, and the mission since then has been flown using the backup receiver. September 5, 1977, Voyager 1 sent the first spacecraft photo of Earth and the Moon. March 5, 1979, Voyager flew past Jupiter in its closest approach to that planet. On July the 9th, Voyager 2 made its closest flyby of Jupiter. Jupiter is the largest planet in the solar system. Colorful latitudinal bands and atmospheric clouds and storms illustrate Jupiter's dynamic weather system. The giant planet was then known to possess 16 moons. Although astronomers have studied Jupiter through telescopes on Earth for centuries, scientists were surprised by many of the Voyager findings. The Great Red Spot was revealed by Voyager as a complex storm moving in a counterclockwise direction, and an array of other smaller storms and eddies were found throughout the clouds. Discovery of active volcanism on the moon Io was easily the greatest unexpected discovery at Jupiter. It was the first time active volcanoes had been seen on another body in the solar system. Together, the Voyagers observed the eruption of 9 volcanoes on Io. Plumes from the volcanoes extended to more than 190 miles above the surface. The Voyagers observed material being ejected at velocities up to 1 kilometer a second. The moon Europa displayed a large number of intersecting linear features in the low-resolution photos from Voyager 1. Higher resolution photos from Voyager 2, however, left scientists puzzled as to what the lines were or how they formed. Voyager showed the moon Ganymede to be the largest moon in the solar system. It showed 2 distinct types of terrain, cratered and grooved, suggesting to scientists that Ganymede's entire icy crust has been under tension from global tectonic processes. Voyager showed the moon Callisto to be a very old, heavily cratered moon, whose crust showed remnant rings of enormous impact craters. Voyager found a faint, dusty ring of material circling around Jupiter. Two new small satellites, Adrastea and Metis, were found orbiting just outside the ring. A third new satellite, Thebe, was discovered between the orbits of Amalthea and Io. Voyager found that as Jupiter's magnetosphere rotates, it sweeps past Io and strips away about 1 ton of material off the moon every second. The material forms a torus or donut-shaped cloud of ions that glow in the ultraviolet, resulting in auroras. November 12, 1980, Voyager 1's trajectory sent it in a close flyby of the planet Saturn, within 40,000 miles of the cloud tops, then closely past Saturn's large moon Titan and behind Saturn's rings. Perhaps the greatest surprises and the most puzzles were found by the Voyagers in Saturn's rings. It is thought that the rings formed from larger moons that were shattered by impacts of comets and meteoroids. The resulting dust and boulder-to-house-size particles have accumulated in a broad plain around the planet, varying in density and forming Saturn's famous rings. Unexpected structures such as kinks and spokes were found in addition to thin rings and broad, diffuse rings not observed from Earth. Radial, spoke-like features in the broad B ring were found by the Voyagers. Winds blow at extremely high speeds on Saturn, up to 1,100 miles per hour. Saturn holds a wide assortment of satellites in its orbit, ranging from Phoebe, a small moon that travels in a retrograde orbit, to Titan, the planet-sized moon with a thick nitrogen-methane atmosphere. Voyager showed the chemistry in Titan's atmosphere to strongly resemble that which occurred on Earth before life evolved. The most active of any moon seen by the Voyagers in the Saturn system was that of Enceladus. Voyager 1 found the moon Mimas scarred with a crater so huge that the impact that caused it nearly broke the satellite apart. The spacecraft's path northward was bent out of the ecliptic plane, the plane in which most of our planets orbit the Sun. Since this was its last scheduled flyby, Voyager 1 began its trip out of the solar system. August 25, 1981. Voyager 2 also successfully flew by Saturn, within 26,000 miles, and it was shown that Voyager 2 would likely be able to continue on to Uranus with all instruments operating. The next year, NASA upgraded 2 of its antennas so they could pick up weak radio signals from the Voyager spacecrafts. January 24, 1986, Voyager 2 completed the first-ever spacecraft encounter with the planet Uranus, a close flyby that brought the spacecraft to within 50,600 miles from the planet's cloud tops and returned detailed photos and other data on the planet, its moons, magnetic field, and dark rings. Uranus is distinguished by the fact that it is tipped on its side, exposing its poles to the Sun. Its unusual position is thought to be the result of a collision with a planet-sized body early in the solar system's history. Scientists were not sure what to expect at Uranus. Voyager 2 found that this sideways position of the planet caused its magnetic field to be tilted 60 degrees. The magnetotail was shown to be twisted by the planet's rotation into a long corkscrew shape behind the planet. The presence of a magnetic field at Uranus was not even known until Voyager's arrival. Voyager detected a high layer of haze around the sunlit pole. Voyager found 10 new moons, bringing the total number of moons known around Uranus to 15. 5 large moons appeared to be ice rock conglomerates, like the satellites of Saturn. The moon Miranda, innermost of the 5 large moons, was shown to be one of the strangest bodies yet seen in the solar system. Detailed images from Voyager's flybys of the moon showed huge fault canyons as deep as 12 miles, terraced layers, and a mixture of old and young surfaces. Voyager showed that the moon Titania was marked by huge fault systems and canyons, indicating some degree of geologic, probably tectonic, activity in its history. Voyager showed the moon Ariel to be the brightest and possibly youngest surface of all the Uranian moons. All 9 previously known rings were studied by the spacecraft and showed the Uranian rings to be distinctly different from those at Jupiter and Saturn. Uranus's rings appeared to be relatively young and probably did not form at the same time as the planet. There was no indication that geologic activity had occurred on the moon's Umbriel or Oberon, judging by their old and dark surfaces. NASA's Deep Space Network once again expanded 2 antennas for better reception of the even weaker signals from the now very distant Voyager spacecraft. Meanwhile, Voyager 1 continued to press outward, conducting studies of interplanetary space. In 1987, Voyager 2 observed a faraway stellar explosion known as supernova 1987A. August 25, 1989, Voyager 2 was the first spacecraft to observe the planet Neptune up close. When Voyager 2 flew within 3,000 miles of Neptune on August 25, 1989, the planet was the most distant member of the solar system from the Sun. It is the smallest of our solar system's gas giants. Thanks to Voyager, Neptune was shown to have 8 moons, 6 of which were found by Voyager. Even though Neptune receives only 3% as much sunlight as Jupiter does, it is a dynamic planet and surprisingly showed several large dark spots similar to Jupiter's hurricane-like storms. The Great Dark Spot on Neptune was about the size of Earth and was similar to the Great Red Spot on Jupiter. The strongest winds on any planet were measured on Neptune. Most of the winds blow westward or opposite to the rotation of the planet. Near the Great Dark Spot, wind speeds reached 1,200 miles per hour. Triton, the largest of the moons of Neptune, was shown to be not only the most intriguing satellite of the Neptunian system, but one of the most interesting in all the solar system. Voyager 2 images showed active geyser-like eruptions spewing invisible nitrogen gas and dark dust particles several kilometers into the atmosphere. The new moons found at Neptune by Voyager are all small and remain close to Neptune's equatorial plane. Names for the new moons were selected from mythology's water deities. They include Naiad, Thalassa, Despina, Galatea, Larissa, and Proteus. Voyager 2 solved many of the questions scientists had about Neptune's rings. With no more planet flybys in its plan, Voyager 2 began its trip out of the solar system. In 1989, Voyager 2 used the gravity of Neptune to slingshot itself, like Voyager 1, out of the solar system. Both probes set sail into the void. Voyager 2 is still the only probe to ever visit Uranus and Neptune. During both Voyager's tours of Jupiter, Saturn, Uranus, and Neptune, the spacecraft sent home nearly 80,000 images and more than 5 trillion bits of data. January 1, 1990. With Voyager's new interplanetary destinations, the project's designation was changed to Voyager Interstellar Mission. Voyager 1's cameras had been dormant since it left the vicinity of Saturn. But on Valentine's Day 1990, before beginning its journey out of our solar system, NASA turned the cameras back on to look back to where the spacecraft had come from and transmit its last images, the Earth and our solar system. By 1998, both spacecraft had shown signs of lessening power supply. Voyager's signals are transmitted by a 20-watt radio transmitter and are so faint that the amount of power reaching NASA's antennas is 20 billion times smaller than the power of a digital watch battery. On February 17th, Voyager 1 passed Pioneer 10 to become the most distant human-made object in outer space. In 2002, the then 25-year-old Voyager 1 was more than 8 billion miles away from Earth. Radio signals required 12 hours to reach the probe. NASA sent commands to activate a spare sun sensor and star tracker to help the craft locate its position. Voyager 1 was leaving the solar system, rising above the ecliptic plane at an angle of about 35 degrees and at a speed of 39,000 miles per hour. Voyager 2 was also leaving the solar system, diving below the ecliptic plane at an angle of about 48 degrees and at a speed of 35,000 miles per hour. Both spacecraft continue to study ultraviolet sources among the stars, and the fields and particles instruments aboard the Voyagers will continue to search for the boundary between the Sun's influence and interstellar space. The Voyager spacecraft are expected to return valuable data for 2 or 3 more decades. Communications will be maintained until the Voyager's nuclear power sources can no longer supply enough electrical energy to power critical subsystems, estimated to be sometime in 2020. On August 1, 2002, Voyager 1 reported that the solar wind speed appeared to slow down. Voyager may have crossed the solar system termination shock. On April 15, 2004, Voyager 2 detected a shock wave from the October 2003 solar storms experienced here on Earth. Voyager 2 measured its speed, composition, temperature, and magnetism. January 5, 2005, after 10,000 days and 7 billion miles away from Earth, Voyager 2 held and still holds the record of traveling to more planets than any man-made object in history. January 21st, also after 10,000 days and 9 billion miles from Earth, in a dark and cold area at the very edge of our solar system, Voyager 1 held and still holds the record as the explorer from Earth that has traveled farthest from home. It was more than 100 times farther from the Sun than the Earth. The infrared spectrometer and radiometer heater was turned off to save power on Voyager 1 on December 7, 2011. The heater was used to keep the UVS, or ultraviolet spectrometer, warm. The UVS temperature has dropped to below the measurement limits of the sensor. However, UVS is still operating. Scientists expect to continue to receive data from the UVS until mid-2013, at which time the instrument will be turned off to save power. There are several other instruments that continue to work. So where are the Voyagers now? Our entire solar system, every planet, asteroid, spacecraft, and life form belonging to our solar system, sits inside a gargantuan bubble of gas about 4 times wider than the orbit of Neptune, and our Sun is responsible for this. The Sun blows the bubble by means of the solar wind. Astronomers call the bubble itself the heliosphere, and its outer membrane the heliosheath. The heliosheath is important to humans because it helps protect us from galactic cosmic rays. Galactic cosmic rays are subatomic particles accelerated to nearly light speed by supernovas and black holes. Cosmic rays can penetrate flesh and damage DNA, so scientists need to learn as much as possible about the heliosheath. Voyager 1 is currently located about 12 billion miles from Earth. It has crossed the termination shock and is now inside the heliosheath. Voyager tells us that we are in a stagnation region where the wind of charged particles streaming out from our Sun has calmed. It is showing that what is outside this region is pushing back. The heliosheath is 3 to 4 billion miles thick, so the Voyagers will be inside it for another 10 years or more before crossing the heliopause and into interstellar space. Voyager 2 is currently located about 10 billion miles from Earth, also in the heliosheath. Voyager 1 will be the first to pass through the heliopause, which is the boundary area between the solar and interstellar wind. Recent data from Voyager has shown that this boundary is not smooth, but frothy and bubbly, and the bubbles are gigantic. Both Voyagers continue exploring where nothing from Earth has flown before. In the more than 34 years since their launch, they each are much farther away from Earth and the Sun than Pluto. Each of the Voyager probes is famously equipped with a golden record, literally a gold-plated copper phonograph record containing photographs, sounds, and salutations from the Earth. Said Carl Sagan at the time, "1 billion years from now, when everything on Earth we've ever made has crumbled to dust, and when the continents have changed beyond recognition, and our species is unimaginably altered or extinct. The Voyager record will speak for us. The disks will be there in the event that sometime in the distant future, Voyager encounters alien life or some future human life. Barring any serious spacecraft subsystem failures or they crash into something we cannot yet calculate, the Voyagers may survive until the early 21st century, about 2025, when diminishing power and hydrazine levels will prevent further operation. Were it not for these dwindling consumables and the possibility of losing lock on the faint sun, our tracking antennas could continue to talk with the Voyagers for another century or two.